everybody. Welcome. Nice of you to join me. So, below the Netherlands, there is a big hole in the ground. You cannot see it. It's way down. And in that hole, there used to be natural gas. But the Dutch gas company, they pumped it all up. They distributed it to the homes. And, well, the hole was empty. And now, the hole was for sale. And another energy company decided to purchase that hole. And they decided to rent out that space under the ground as a bank for natural gas. And what they do is they sell the product to their customers, and they allow their customers to inject gas when it's cheap and to get it out again when it's expensive. And by the price difference, they make their profit, and the energy company makes its profit by selling that commodity. So what happens is that the customers who use that bubble, they ask the energy company to either withdraw or inject gas. Well, there is a bit of a problem there because the gas that is pumped into the network also needs to be consumed on the other end. So there's very little buffering in the network. And that means that the injection and withdrawal requests, they need to be processed whenever they are made. So there's no slack. What's also important is that the demand is variable. So during the day, the consumption is high. During the night, the consumption is low. So I built a system, and the experiences I picked up during the building of this system, I'm here to show you how we did it. And this talk will be focusing on security. Well, you may wonder, why is security this important? Well, this is just a small segment of the hacks that were made in the past year. And there are some big names here: Microsoft, Dell, Toyota, Marriott, and it's all millions of accounts that were leaked. And, you know, there is just a big war going on. The last black segment is from Have I Been Pwned by Troy Hunt. And it shows that the largest hack up to date was 700 million user accounts. That's insane numbers. So, fundamentally, Michael Hayden says, fundamentally, if somebody wants to get into your system, they will get in. Accept that. Also, you're in the fight, whether you know it or not. And third, you are almost certainly hacked. Well, this is a nice shift of paradigm. So instead of focusing on the controls, keeping this enemy out, you should focus more on what you can do whenever you are compromised. So move from preventing to assume breach. And this talk, I will perform from this perspective of a hacker and show you how you can add controls to your system and make your software better. Well, in the classical security model, you would have a security audit once a year, and just before it, you would make sure that everything is up to speed, so you pass the audit, and then you start slacking off again. Well, it happens, you know. Well, in this world, to make your software very secure, you need to think about a lot of things. So these are just a few things that you need to worry about. This is not the complete list of everything, but these are just a few things. And, well, during this talk, I hope to familiarize you with at least 80% of them. So you need to check all these things, and you also need to release 10 times a day. So this is this is a DevOps mindset. You want to deploy straight to production. You want to do testing over there, and you deploy your features maybe multiple times a day. Well, that is just an accident waiting to happen. So if you need to check all these elements I showed you on the previous slide, you will have a problem. So, what to do? You can fix this by making security not an afterthought, like the yearly returning security audit, but you need to incorporate it into your development lifecycle. And what you get then is a security development lifecycle. Well, Microsoft is one of the companies who defined their own security development lifecycle. And it consists of best practices, processes, standards, activities, and tools. It's basically dividable into 3 categories. So you have to have awareness, so you need security training so that everybody realizes that they are under attack. So they are, because Michael Hayden says so. From that point on, you need to be able to know how you can prevent this. And if you are assuming breach, then you also need to know how to respond to incidents. Well, the security development lifecycle will help you create a process around this. If you look at the flow over time, then you can see it starts with awareness. You need to have training first. A part of training is war games. You need to sit together with 2 teams in the same room, or different rooms, whatever. And one team will start hacking your solution by every means they know, and the other team will try to keep you out. And if you think like a hacker in that way, and think like an ops, sec DevOps defender in the other way, you will get familiar with the process. And if there's ever a real incident, you will have some experience and know how to deal with it. Then it's time to set up a baseline. Well, a baseline is intended so you can know how you stand. So you can know how good your current security processes are. So that can be it can be absolutely nothing, it can be quite good, it can be extremely high, but in order to know where you are, you can do this OpenSAM assessment. So OpenSAM is an open source model, and you fill out a bunch of questions, and based on that you get a security score. And from then on, if you do that periodically, you can see any increase in security level or decrease in security level. Then it's time to design your software. So a good practice for designing software is to do threat modeling. Threat modeling is, well, sitting in a room with your team and thinking ahead about what can happen with this bit of software. How can people attack it? How can it be misused? And, well, all these things need to come together before you start building your software. It's also a good moment to define some security and privacy rules. So you need to know how you will deal with personal data, for example. In the build phase, you need to come up with a list of approved tools. So you cannot just have any developer getting any package from the street they seem to like, or get it from NPM, and just start using it. If you have a process around it, you mitigate the risk of somebody introducing a rogue package. You can also apply static code analysis. So this is an automated process, and it scans your packages for vulnerabilities, for example. I'll show you a little bit more later. And then after the software is built, you can verify the security practices by applying something that is called fuzzing. So imagine you have an API, you just start sending all kinds of interesting and incorrect data to it, and you see whether it ever responds with data you were not supposed to see, or crashes, or takes a really long time to respond. And then, obviously, it's time for pen testing. I do recommend you hire somebody specialized in this, because this is a separate, separate job altogether. You need somebody very experienced for this. Well, as you can see, this is quite linear, and I was just talking about DevOps and continuous deployment. So this is usually about iterations. Well, like I said, you cannot check every security aspect for every feature you deploy to production. So what I do recommend is that you automate whatever you can automate, for example, static code analysis. And then for every sprint or for every feature, you pick a few items out of the 3 categories, design, build, and verify, and check those. And then you do need to make sure that there's no starvation. So you need to check at every element of the list at least once every 6 months. So you pick one task from every bucket for every feature that you deploy. If you want to protect your software, you will need multiple layers of protection. This is because a single layer of control can obviously fail. So if you have a big castle protecting the crown jewels, a catapult may destroy your walls, the knight may be defeated, the king may be poisoned, and you may get a Trojan horse ridden into your castle. So what you want to have is multiple layers of defense, like the moat, the knights, the big tower, big thick walls, and all these together, they will protect your system. This obviously also helps thinking from the breach perspective. So if you are a hacker and you've just compromised the castle walls, so you're inside, then it should still be very hard for the hacker to pivot from there and start hacking other stuff from there. Well, in order to demo this to you, I've created a small demo application from the system I mentioned earlier. This is a simplified version, of course. It consists of a React front-end. It runs in the browser. It talks to a web API, which is running in Kubernetes. And this processes those injection and withdrawal results requests. It also does background processing. So it collects those requests and periodically ships them off to the plant, which is another API, but it's also only running internally. I'll just quickly show you a nice demo. This is it. Just refresh. So now I'm logged in. I protected this using Azure AD, so it's nice and secure. And then this is the screen. And for example, if I'm Northwind Traders and I want to withdraw some gas, I can just click this. And then after a while, I'm not sure if you can see it in the back, but this 11 should drop to 10. Yeah, well, it's very simple. Well, if you zoom in a little bit on the fill level call, I'm not entirely sure if that's, yeah. You can see I specified content security policy. That's just one of the security headers, but this one is especially nice. And it defines for all the objects I can use on my web page, which sources I can use. So, for example, my JavaScript can only run from this page inline or from the main URL that runs this application. Yes. Well, if it's time to start threat modeling for this application, I like to use the the Stride acronym. This is just one of the models you can use, not the definitive one. I like this one. Stride is an acronym that stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. If you apply these and also apply their countermeasures, so for example, tampering of data, you can counter that by providing access control, and you can counter it by providing TLS encryption. So data on the wire cannot be tampered with, and data in storage cannot be tampered with. These are just a couple of examples. If you want to apply this Stride pattern to the demo application, you would create something that is called a data flow diagram. And it shows data flowing from one system to the next. And this is a simplified model of my application. So it shows you the front end, doing web requests and getting web responses from the back end, and the back end calling the plant. Well, the nice thing of the Microsoft threat analysis tool, I'll show you a little bit. This is the tool itself, the Microsoft threat modeling tool, is that if you do this and you then click Analyze, it will already show you all the elements that you need to be aware of from the Stride perspective. So it generates a list of Stride attacks, Stride-based attacks, and their mitigations. So, for example, you need to make sure to prevent tampering, you apply SSL instead of just plain HTTP. Well, if you check all these, you will get a baseline, and then whenever you add something to your system, drop it in the diagram, and it will reanalyze and show you the new Stride analysis measures. All right. Oh, that's... the Microsoft threat modeling tool. So. All right, now let's shift to Kubernetes, because that's the main idea of this talk, of course. Inside Kubernetes, there's also a lot of stuff you can do and stuff you need to think about. Well, I'll introduce you to the most important ones from my point of view. So the first one is pod security policies. So this is a policy that defines for every pod on your cluster what it can do and what it cannot do. And this is especially important because not all the images that you use to create your containers on, like the base images, are equally safe. So some have a passwordless root account, for example. That means that you can just elevate the root from within a container, even if it wasn't root to begin with. And it's not something that happens very rarely. It's actually quite common. So what can you do? Apply pod security policies, which, like I said, it's a policy for every pod on your cluster. And you can specify disallow running as root. You can also deny access to the host, which is also very convenient, because if your container is compromised, then it will make it a lot harder for the hacker to escape from the container and attack the host it's running on. And the host is where the good parts are, right? In Kubernetes, at least in AKS, the host has a file which has credentials to manage the Azure subscription it runs on. So these are very valuable. You don't want them compromised. Another thing is enabling seccomp and AppArmor. These are policies on Linux on the process level, and they specify which kernel calls a process can do. And if you strip those away as well, it makes it even harder for the hacker to use your container as a platform to pivot from. It's also a good practice to make the file system that runs the container read-only. So a hacker in your container cannot go to the web and download some binaries and use that to hack your system further, like Mimikatz or network sniffing. Well, I'll show you a little bit about how this works. So, this is readable in the back, right? Yeah? Okay. What I did first is define a restricted policies. And these annotations are for seccomp and AppArmor because they are still in preview. If they go to GA, then they will appear in the spec here. So what I did is I said privileged is false, so containers cannot run as root, but you can also not elevate privileges and run root from a regular user. I defined which volumes your container can use. I deny access to the host. And I mount the file system as read-only. So this is my default policy. And by only applying this, it will every container that gets spun up from this point in time, it will be protected. And well, I can show you by running this nginx as root. And this is the Kubernetes pod definition for it. Nginx, well, it's an ingress controller, reverse proxy, web server. You can use it for a lot of things, but by default, it uses port 80 and 443. And for this, you need some privileges. So the default way of running this is running as root. My policy denies this, and so even though the pod is created, if I go to Kubernetes and scan for that pod, you can see it's red, and if you're colorblind like me, then you need to read this, and you can see that it gets an access denied. So this guy won't start on my cluster. So the pod is created, but the container is not running. A similar thing is running nginx with privileges. So I will apply security context privileges, which pretty much adds privileges to the container from the Kubernetes perspective. But like you see here, my pod security policy prevents this from happening, and this pods won't even be created. So it's a protection as well. Obviously, I do run my own pods here. So if I look at the production namespace, then you can see my backend and frontend and planned pods just running happily. And this is because they do not run as root and they do not do anything naughty. And if you look at the YAML that's created for such a pod, then you can see the AppArmor and the seccomp and all that nice protection is applied here. And it comes from this, the pod security policy, or PSP, is restricted. Keep in mind, if you do kube control apply, then you run a sysadmin. Usually, all security policies are ignored. So I'm running this as the service account I specially created for this. So this is my account that is specially created for deploying pods to this namespace. All right, so getting started with security policies is, well, quite complicated. You need to have a good understanding of RBAC first. You need to make sure you test on a separate cluster, but it's quite easy to lock yourself out if you do it wrong. it's a good practice to create special deployment service accounts and separate running service accounts. So you deploy using account 1, you run using account 2. So you can apply just enough rights to every service account. Well, a second major element is container networking. Containers, by default, can talk to each other. Every container can talk to every other container. This is insecure by default. So what you want to do is to create a default deny policy. So you can only talk to other containers if I say you can. And it would be even better if you specify to which containers you can talk. And using network policies, you can do that. So a nice demo for that as well. So if I go to my, sorry, need to open a terminal to the backend here. I'm connecting to the container running as backend here, and I want to do curl min v http front end. I want to call the front end from the backend. Well, this is obviously very unusual, so this is not something I need. So if I want to deny that, I can apply a policy. It should be here. If I now go back to my backend pod and try to talk to the front end, I'm denied. So this doesn't work anymore. Well, the unfortunate side effect is that by denying all traffic in my cluster, I can also not use my front-end application anymore. So that's kind of nasty. So what I want to do is allow some egress from the backend pod. So I can do that by applying a policy specifically for the backend. I'll explain later. Applying this, I'll quickly show you that I'm not... Yeah, it works again. But from the front end, I cannot connect to the back end. From the plant, I cannot connect to the front end. But from the back end, I can connect anywhere. I just specified it in this policy, which says allow backend and every egress. So if you see the square squiggly brackets, it means everything. So backend is allowed egress. But all the other parts are not. So I now hammer down my cluster for a bit. All right. So a couple more Kubernetes tips. It's important that you realize that secrets are not secrets at all. So secrets are just base64 encoded strings if you use the default secrets provider. So keep that in mind. If you put TLS certificates in there or connection strings, realize that they are not protected. You could use HashiCorp Vault instead. Also, API tokens are mounted to service accounts by default. So what you can do from any pod is just call the Kubernetes API. And if you have not enabled RBAC on your cluster, this token is a sysadmin token. So you don't need it, get rid of it. You can also look at the cloud, escape your cluster and look at the cloud. And AKS runs in something that is called a network security group. And by default, it's very permissive. You can also hammer down there. So if you want to protect your services a little bit more, you can also add a layer of protection in the cloud by adding rules to the network security group. And finally, if you want to see how your containers are doing in production while they are running and detect any anomalous behavior, you can use a tool like sysdig, for example. It's also important that you know that Helm, the default install of Helm, deploys a tool called Tiller, and it's unsecure by default. So if you use Helm init, for example, you'll be in trouble. It's fine if you use it, but make sure you get rid of it. And Helm 3, the coming up version, it will get rid of Tiller, so you'll be more protected. It's also important that you realize that you need to reboot your cluster nodes yourself. So AKS in Azure will patch them for you, but you need to drain them and reboot them. And there are tools for that, but you need to do it yourself. Well, to get optimal security, make sure that you start on your dev machine first. So keep credentials in a password manager. Don't store them on file tag, plain files in the repo. Keep connection strings in the key vault. So use a secure environment for your connection strings and get them at runtime. Scan your code for credentials. So well, everybody makes a mistake sometimes, adding a connection string somewhere. You could use tools like CredScan and scan your environment before you commit your secret to source control. And also have a look at Kali, which is a hacking toolkit. It's a free distro of Linux, and you can just download it and start using it. It's for free. So this is just an example of CredScan at work. You get a nice build warning if you accidentally type in credentials in a file somewhere. It works for every project. So if you move from the dev machine to the release pipeline, you can also do cred scanning over there. So you won't accidentally deploy them to production. And you can also start scanning your packages for vulnerabilities and for updates. And what's also important is to scan your base images for vulnerabilities. And some container registries will actually do that for you. As a hacker, I can be an employee as well. So maybe I'm a rogue employee. I'm about to get fired and I know it. So I want to do some real damage there. So make sure that a developer in a mission-critical system cannot put his own code to production. And you can do this by enforcing pull requests before you merge to master. And you can also have release gates in your development pipeline and make sure that somebody else needs to approve a change before it can be pushed to production. You can further narrow the risk down by automated deploying of everything. So you deploy a cluster using infrastructure as code, and you deploy your software using the delivery pipeline. And no developer ever needs to have the production credentials in his hand. You can also apply a bunch of scanning tools in a separate pipeline. So what I did here, I created a separate scanning pipeline. And this is just continuous integration. So whenever I do a pull request or I merge something to master, this build will fire and it will scan my repo for credentials. It will run TS-lint for the front end, and all kinds of security analysis is performed here. And afterwards, the results are analyzed, and if any vulnerabilities are detected, my build will break, and I will get notified. So another way of doing this is by using either White Source Bolt or SonarQube. SonarQube, well, the free version at least, you can see it work here. It can also analyze your code for vulnerabilities. However, by using the free version, your code will become open source immediately. So you can see here, I'm not logged in, but this is my actual code shown here. So aside from vulnerabilities, it also scans for maintainability and a whole lot of other stuff. So this is a very useful tool, but the free version should be used for open source only. I just did the demo. So a call to action for you. If you use Kubernetes, please, please, please use pod security policies, because they will help you, and it's secure by default, and you apply exemptions later. If you want to create threat models, have a look at the STRIDE acronym. Apply defense in depth, so add multiple layers of security instead of one. So assume breach, think like a hacker, and okay, so this control is breached, what else can we do? You saw me introduce a whole bunch of controls. And well, play war games. Like I said, divide the team into two groups, and one will be the hackers and one will be the defenders. Stay safe. Thank you.